Oops. Yeah, everyone, listen now. So Kadant's algorithm. So what it says, so it is used to find the sum of maximum sum of summary. So there is no specific length mentioned here. When there is no specific length mentioned, it is clear. But sometimes you can take till the entire array also, which is taken as what's a subarray. So that what you can understand here, you can understand here that tell me everyone sir, the get it sir. When you have only positive elements sir, definitely the entire array sum will be the maximum. That you can do. When you have only negative elements sir, whichever is what's a minimum out of that, you pick up with respect to what's tell me the positive value and keep that what's negative and that will be the maximum. Okay. But especially the problem comes when you have positive and negative elements. So now let us see how we are proceeding some with this Cordon's algorithm, especially when you have, tell me everyone sir, an array with positive and negative elements. So here the two important points you have to proceed. So our requirement is towards find the maximum sum. Hello sir, please. The white shirt wala. Please take your seat. Right. Okay. So because our intention is to find the maximum sum of subarray, you start with one element, you increase the length of the subarray, then go to the next element, then you add those two elements. And if the sum is more than our previous, it's good, it is increasing. It's good, it is increasing. Then what you do? You maintain the same subarray, but you extend its size. You go to the next element like that. As long as your sum is, tell me, more than the previous number. I hope understand. So when you add the current element to the previous element, if the sum is more than the previous element, you are continuing that subarray. Ever read sum? Yes. But, sir, when you are adding the next element to the previous element, when you are adding the next element to the previous element, if sum is decreasing, the sum is decreasing, or sum is going less than 0, then will you consider the addition of the next element to the previous element sum? Tell me, no. Why? Because the sum is becoming negative or sum is decreasing. But we want what kind of sum? We want what's the increasing value. We want maximum sum. When we want maximum sum, when you are keeping adding that element, its value is getting decreased when you add next element to the previous element. Better you discontinue that subarray with the previous element. Start new subarray from the current element. Am I right, everyone? Am I right, everyone? Yes. So these are the two important points you have to consider, sir, with respect to this Cordon's algorithm. Now let us see how it works with respect to this algorithm. Then you get clarity. Are you getting my point? Tell me once again, what are the points? What are the points, sir? The points, sir? Tell me. The first one, sir. Yes, we want to find the maximum sum. So you start with first element, you go to the second element, you add the second element to the first element. If the sum is more than the first element, it's good. It is increasing. Then you continue that and go to the next element and add it. Go to the next element and add it. Okay. As long as it is increasing. Okay. But whenever, sir, I add the next element to the already existing sum till now, if it is going below that sum or below that number, it's negative, definitely what's up, that will not contribute to the maximum sum in future. So what you do, whenever you add next element to the what's the previous sum or previous element, when sum is decreasing than already existing what's the previous element, we drop that, tell me sir, the subarray and start a new subarray with the current element. Am I right, everyone? Am I right, everyone? Yes. That's a point, sir, we have to consider. Look at this carefully, everyone. So here, let us follow that procedure and see what is the maximum you will get it. So every time you update that maximum sum with current sum, what you have it. Okay now? Right. Whichever is maximum, you pick up now. Okay. Yeah. Look at this, sir. So I am starting with -2. So -2 plus 1. What is becoming? -2 plus 1. What is becoming, sir? -1. It's good. It's more than that. So I am extending this subarray. Okay, I am just now coming to -3. So -1 -3. What it is becoming, sir? minus 4. It is going far below the current element. What, sir? Tell me 1. Am I right, everyone? Tell me, yes. As of now, the sum is available is minus 1. But when I add the next element to this current sum, it is going far below. It is less than our 1. Am I right, everyone? Tell me, yes. Or the sum is minus 1. It is even less than our sum at this place, or it is less than our current element also. Am I right, everyone? Am I right, everyone? Yes. Yes. You don't further extend now. Then what you do, because sum is going towards below, then what happens, sir? You leave that previous summary and start the words of new summary. I hope you understand. I hope you understand. Yes. Okay. So, sir, first I am starting with minus 2 and extending it to 1, so it's increasing, so further extending. When I am further extending, it is going far below. It's negative. I hope you understand. Negative. Definitely it won't contribute to the maximum sum in future. Because already got what to tell me? Minus 4. So that's why. Now let us drop the summary till this place. Whatever we took before, previous one, let us drop it. Now start a new summary here. Start a new summary here. I hope you understand. I hope you understand. Tell me, yes. Yes. Now I'll start with minus 1. Okay. Sir, why are you starting with minus 3? Why are you missing that, what's a minus 2, 1 also? Why don't you start with 1? Even you take 1. 1 minus 3, minus 2, it's going below negative. I hope you understand, yes. Already that summary we have already evaluated. Minus 2 plus 1, it's okay, increasing. Then we are extending further. That is reducing what's a sum far below than the current element or the current sum. Both it is what's a going less. So better you stop that summary and start a new summary because it is going far below the expected value. Am I right, sir? Yes. Yes. So that's why what I am doing now, I am starting here what's tell me. For example, at minus 3. So minus 3 plus 4, how much, sir? 1. It is increasing. I'll continue now. 1 minus 1, how much, sir? 0. And again decreasing. Again decreasing. Am I right, sir? Yes. It's becoming 0. Okay, right. So definitely it won't contribute to further. Let us start now new summary at 4. Come on. Let us start new summary at 4. Now let's see what you get. 4 minus 1, 3. Okay, not a problem. Just decrease by 1. It's not negative still. Then 3 plus 2, 5. 5 plus 1, 6. Yes. Yes. Till this point you are getting 6. Yes. I hope you understand. Yes. Then 6 minus 5. 6 minus 5, 1. Let us not consider that because I want to take only summary with maximum sum. Okay, no? Right. Okay. Suppose if I drop this 4 and continue further, minus 1 plus 2. How much, sir? Minus 1 plus 2. Minus 1. Sir, plus 1. Increasing. Plus 1 plus 1 plus 2. Plus 2 minus 5. Minus 3. Plus 2 minus 5. Minus 3. Again decreasing. Again decreasing. I hope you understand. You drop this point also start with 2. 2 plus 1, 3. 3 minus 5, minus 2. Minus 2 plus 4, 2. But still it's less. Here we got 6. This is only the correct point where we got 6. Am I right, sir? Yes. Nowhere else we got 6. I hope you understand everyone. Okay? Right. Suppose if I take from here to here. Okay, like this. 1 minus 3. Minus 2 plus 4. 2. 2 minus 1. 1. 1 plus 2. 3. 3 plus 1. If that is also not maximum. So this is the place where we got maximum. I hope you understand everyone. Where is that, sir? Yeah. Why? This is the maximum, no? We got it? What is that? 4 minus 1. 3. 3 plus 2. 5. 5 plus 1. 6. No other summary will get maximum. Am I right, everyone? Am I right, everyone? Tell me. Yes. That means, so here you have an important point that, sir, when you are adding next element to the current sum or current element, if it is exceeding, yes, you continue. That means your maximum sum, you take it. If it is decreasing, then what you do, sir? Whichever is maximum out of that, from there you start your sum freshly. Am I right, everyone? Yes. You can start with that number, or you can start with, continue the summary by adding that number to the previous one. Are you getting my point? Yes. That's what we are saying. That's what we are saying. I hope you understand. Okay. So this is called cadence algorithm. But every stage you have to identify. Tell me, sir, the current sum and max sum. Am I right, everyone? Am I right, everyone? Yes. What is your current sum, sir? I start with one element. I add that next element to the what's tell me the previous element. So whichever is maximum, that only my current sum. Am I right, everyone? Yes. That means either I am continuing the subarray or I am dropping the previous element and starting the new subarray from the current element. That's the meaning of it. Yes or no? Yes. I hope you understand. Okay? Yes, sir. So this is called cadence algorithm. So let me just now quickly conclude the points, sir. Then we'll start implementing this using the code. Okay, na? Right. So cadence algorithm gives, tell me everyone, sir, the maximum sum of subarray. There is no specific length here. There is no restriction. You can take your entire array also. Yes. So how do we proceed in cadence algorithm? So cadence algorithm, if you follow a procedure, if you want to get the maximum sum of subarray, there are 2 points you have to keep it in mind. One is, so start with one element, continue the subarray to the next element. When you add the next element to the current element or current sum, if it is exceeding the current sum, proceed that subarray. Continue that subarray. Okay, try to find that sum. But if it is going below the current sum, okay, when you add the next element to the current sum or the previous element, when it is going below the current sum, to continue that subarray, stop the subarray and start a new subarray with the current element. Am I right, everyone? Am I right, everyone? Yes. So this is called, tell me, cadence algorithm. So cadence algorithm just gives us updating the maximum sum at every point just by adding the next element to the previous element. When you add next element to the previous element or previous sum, if it is exceeding than the previous sum, you are continuing, that means you are picking the maximum there. And if it is going below, you are picking only the current element and leaving the previous sum. That means you are discarding the previous sub array and starting a new sub array from the current element. Okay, now whichever is maximum, that only you are taking it. I hope you understand. And then every time update your maximum based on the initial maximum and current sum what you have it. Okay, so shall I write down the code? Shall I write down the code based on this procedure, sir? Tell me yes. Okay, so we'll quickly first do an online compiler, then come back to lead for 53. We'll submit. Okay, now? Okay, right. So now let us see everyone. Now let us see everyone. The answer is 6 now for this answer. For this question?
Yes.
Yes, we got 6 now. We identified the 6 using cadence algorithm. Yes. So now let us see that. Now let us see that, sir. Sir, it's very, very simple. Only the thing that your mind should gain that point. That's all. So that's how I'm explaining visualization also with examples. So just keep that concept towards understand it clearly, then fix in your mind. So you can now do any kind of problems on this WhatsApp cadence algorithm if you understand it. Every pattern is like that. Okay? If you know some pattern, you can solve some sort of problems. So never learn lead code or let's say the competitive coding just problem by problem. No, pattern by pattern. Learn pattern, solve all problems related to that pattern. Try to solve as many as you can. Then go to the next pattern. Keep on solving what the problems based on it. Because see, sir, how many problems approaches will remember, sir? It's very lengthy. Am I right, sir? Yes. So let us solve the problems logically using the pattern. I hope you understand. So learn the pattern, solve the problems. So you need not remember every approach to solve every problem. Just we know the pattern, how it works. Apply it to the problem, that's all. I hope you understand. I hope you understand. Okay, that's the way you can best learn DSA. Otherwise, if you're learning problem by problem, I am sure you'll fed up with within 20 problems and 15 problems. You'll get completely frustrated, you leave it. So how can we learn? So there is a systematic way of learning. So that you must follow. So that's about that you'll be learning in training class. Okay? I hope you understand everyone. So that's why you have to, everyone has to undergo this CRD training. Because there you'll learn the techniques. No one will teach you this in any regular class. I think no one will teach you normally also like this in regular class. Because they don't know first. The staff itself they don't know that happens. Because they are only towards means instructed to teach your syllabus. Maybe keeping some PPTs and move on, over. Even hands-on also, I don't know how many of you are doing. Means how many of what's the in your regular class, how many are doing hands-on like this and showing with the video. Okay, this is required. This is required. That's the difference between a normal class and regular class. Okay, I mean training class. You must learn. You must learn everyone. Okay, that's why training class is provided for you. It's not to waste your time and all. Everyone. Okay, right. So listen now. Maybe for first 3 days I discuss fundamentals because I want to just give clarity on the fundamentals, then move on. Without knowing all that, we would have not done this. See, now we have stuck up the hoops because we didn't see hoops. Am I right? Yes. That's the reason, sir. First 3 days I was giving you all the fundamentals. Okay? Right. I told you also in the beginning. But many of you are feedback, they are saying, sir is only covering basic now advanced. But when I started advanced, now everyone is sleepy. Okay. Right. So try to follow it. Try to follow it. Right. Okay. So let's begin. So one more component I'm starting, sir. So the approach what we are following is a standard approach. Come on. This. Switch on this. Max, sum, sub. Maximum sum of sub array. That's what I want to say. What it takes, sir? It takes only the inputs nums. That's all. No other inputs. Am I right, everyone? Am I right, everyone? Yes. No need of left, no need of right, and just what's a nums. Okay. Now let's see. Yeah. Let us start. Now define some variables. So initially, I am defining our current sum. Current sum is equals to 0. Okay. I am also defining maximum sum, which is equals to. Shall we take minimum value? How do you take minimum value? Float of min. No. Maximum initially we take minimum value. Shall we take 0 directly or no? But sometimes we have negative, then 0 will be only taken as maximum. Yeah, we want maximum only, na? Yes, okay. Let us see. Let's see. Okay? Otherwise, actually, you should take minimum value. In Java, we take integer.min. In Python, how do you write something? Maximum, we write float of infinite. But minimum means float of minus infinite. Huh? Is that? Oh, we'll see. Let us keep it 0 and see. Okay? Right. Okay, now let's see some. I took two variables initially, current sum 0, initially max sum also 0. Okay. I think I need not take 0, sir. I can take like this first. So initially, my current sum is first element. Our sum start with the first element. Nums of 0. And our max sum is also same nums of 0. Tell me, yes? First element. Only when you take first element. Second element onwards we calculate. Okay, now for I in range of from where to where second index. Sorry, second index 1 till the last element. Length of nums. Length of nums. Yes, sir. Now we have to calculate. Tell me your current sum and max sum. So whether you are taking, tell me sir, extending the summary or you are starting the new summary. Based on, tell me, whether sum is, when you are adding next element to the previous element, whether the sum is more than that or whether the sum is what's up? Less than the current element. So based on that, whichever is maximum, that you have to pick up. Am I right, sir? Yes. That one will become your current sum. Then update your maximum sum by comparing with the initial max sum with the current sum. Am I right, everyone? Yes, every place you have to update what is the maximum. Am I right, sir? Yes. You are picking up current sum just by comparing what's either extending subarray or starting new subarray. But what is the maximum sum at every step also? You have initial maximum sum. Now you have currently some current sum, which is maximum. That you have to pick it. That is your max sum. Am I right? Yes. So that's how we are proceeding. My current sum is equals to I have two options now. Tell me what is that? Sir, the current number, you have to add it to the previous current sum. Am I right, sir? Yes. That you have to compare with the current number. Am I right, sir? Yes. So if it is more than the current number, that means you extend. If it is less than the current number, you drop that, start the new summary from the current number. Am I right, everyone? Yes. So I am writing now, current sum is equals to max of, what do you say? Max of, tell me everyone, sir, nums of I, that means current number, comma, previous sum. What is previous sum? Current sum, you have some initial sum. To that one, you add now the current element. Am I right, everyone? Am I right, everyone? Yes, sir. Either you add the current element to the previous sum, you see that sum, and you see the current element. Whichever is maximum, you take that. Suppose if the current sum plus nums of I is maximum, what does it mean? You are extending that summary. You are adding in that summary. So, if it is less than the current number, when you are adding next element to the previous sum, it is going below the current element, then ignore the previous. Then what? Start with the new. Am I right, everyone? Yes. I told you with respect to negative, but here with respect to what's up? Num. I hope you understand. Two options. Okay? That's how you will find your current sum. Either you are extending the subarray or you are starting the new subarray. Whichever is maximum, that you are taking. Am I right, everyone? Yes. Why are you taking maximum, sir? Because I want to get maximum sum. Because I want to get maximum sum. I hope you understand. I hope you understand. This is the point exactly what we said initially. So there are two situations we have to consider. What is that? When you add the next element to the previous element or previous sum, if it is more than the what's the previous sum, extend the subarray. If it is going below the what's the previous sum, let us start the new subarray from the current element. Am I right, everyone? Yes. The same thing I have written. The same thing I have written. I hope you understand. This is the what's the core part. You have to everyone get clarity, sir. So once you get current sum, update the max sum. What is max sum? Before I have some max sum. Now I got some current sum. Compare the current sum with the initial max sum. Whichever is the maximum, you pick up that. That's your max sum. Am I right, everyone? Yes. I am doing now. Max sum is equals to maximum of. For code is only 2-3 lines. Understanding is required. Just very simple. Maximum of. So initially I have some maximum sum. At every place I am identifying what is maximum. So initially I have some maximum sum. What is that maximum? But now I got a new sum. What is that new sum? New current sum. Whichever is maximum, you pick up that. That is your maximum sum. Are you getting? In the first case, what you are doing is you are trying to find the sum of the subarray either by extending it or by starting a new subarray. Second case, what you are doing? So when you start a new subarray, initially you may have some maximum sum. Now currently you have 10% some maximum. Okay, whichever is maximum, you pick up that. Because I am trying to get here maximum sum of subarray. You should always keep track of maximum. I hope you understand. That means after every step you are either starting new subarray or you are starting extending that subarray. You are finding that maximum sum. You are finding that maximum sum. Okay? Yes, sir. That's also over only these 2 lines of code we should know here. Very simple. Okay? Now come out of this for loop. Over whenever the for loop is repeated, yes, you will be evaluating the current sum based on either extending or dropping it, and every time you will be noting that maximum sums are. And finally, whatever the maximum you have, you return that. Whatever the maximum you have, you return it. Over. So return max sum. Return max sum. I hope you understand. I hope you understand. Okay? So this is called cadence algorithm. Very, very, very simple code. Just understanding what's the algorithm is important. I hope I am clear with this, everyone, sir. Shall I go to now driving code? Shall I go to now driving code? Yes. The method, the max sum method we have written. Now come out of it and come to the what's D level, def level. Give the inputs and call the method. What is the input? Only one input, nums. So can you give me the first array mentioned in test case report number problem number 53? With us here directly. You said that one. Same minus 2. Next one 1. Next one minus 3. Next one 4. Next one minus 1. Next one 2. Next one 1 minus 5 4. 1 minus 5 and 4. Okay then I just took nums array. Now let us call the method because it's returning a value. Let us call that method inside the print statement. So what is the method name? Max sum sub. Max sum sub of nums. That's also just 2 lines in our main program are driving code. Just 2 lines. Define nums and call the method. Pass the method. Nums. That's all. Shall we execute now? Shall we run it, sir? Yes. Let's see now what we get it. Yes, I got 6. This is absolutely right answer. Am I right, everyone? Tell me. Yes, sir. Yes. We got correct answer. So now shall we test with the second test case also? Answer. Yes. Give me the second test case also. Give me the second test case also. Everyone. Come on, tell me numbers. Otherwise, I'll copy it. Not at all. I'll copy it. I think I didn't open another. We'll open now. 53. Lead code problem number 50. Yes. It's a medium level problem. Let us take the words of second one. Just one element. 1. Okay. You get the same. Let us just make it 1 and let us see what is max. Okay, no? Let us run and see. Run and see. Yes, I got 1. I got 1. Everyone can see that, sir. I got 1. The second test case is successfully passed. Now copy the third test case if you are ready. Yes, third test case is given. 5, 4, minus 1, 7, 8. Control C. And just copy here. Yeah. Now let's see what is the answer. Okay. This is arena 5, 4, minus 1, 7, 8. Third test case. Now let us run and see. Yes, I got 23. 26 is required output now. See once. Is that 23? Yes, output should be 23 now. We got 23. I hope you understand. I hope you understand. All the 3 test cases have been passed. Can we directly paste that code here and run it, sir? Please answer. Yes, I am just pasting that code now and run and submit. So where is it? From here you have to copy. From here you have to copy. Till written. Till written. Okay now? Only body of the function you copy. Driving code is not required. Okay now? Just body of the function. Control C. Control C. And come to this point.
For I in range LM.
Okay. Now after this, Control V. Just paste it. That's all. Just paste it, sir. Let us give all of them and see. Come on, look at the spacing. Okay. Just inside you keep it. These are all indentation. Written is at the level of 4. Okay, done. This is the code. Simple code. Clear, everyone? Our array name is also here. Nums. We also took nums. No need to modify array name. Array name is clear. Only one input, that is nums. I hope you understand. Shall we do it, sir, everyone? Shall we implement? Yes. Now I am running. Let's see what happens. Look at this. Yes, sir. 3 test cases have been passed. Just now we verified all the test cases have been passed. Yes, here also passed. I hope you understand. I hope everyone is submitting along with me. Okay? Right. So, yes, sir. 3 test cases have been passed. Simple. So, shall I submit now? Shall I submit, sir? Tell me. Yes, I am doing because all the 3 test cases, no errors, nothing. Yes, let's submit now. Sorry, again running, sir. Submit. Yes, I accepted. Now submit. Oh, good. We got only 32%. Submitted and sent. Clear everyone? Clear everyone? I hope you understand. Okay. Yes, sir. We could pass all test cases. How many test cases? 2 test cases. Yes, all are passed.
After submitted.
2 test cases we are able to work, sir. And that means our code is now universal. Generalized. Any test case, yes, it will be working. So that's about Cadence algorithm first problem. I hope you understand everyone. Okay? Still anyone has any doubt? If you have not submitted, please complete it, sir. I'll wait. If you have any doubt, you ask me. Any question? Tell me.
तेरा कोड रन होने से मतलब है कितना है वो चेक नहीं करते समझा
Full of comments.
यूएस कोड अरे इसमें अभी इसका देख वो एल्गोरिथम लगाया ना वो लीड कोड वाले ही देखते तेरा प्रॉब्लम सिर्फ इतना रन होना चाहिए तो तेरा जो कॉन्सेप्ट रहता है लॉजिक कुछ नहीं अंदर जाने प्लेसमेंट के लिए होता है लॉजिक तेरा बिल्ड लॉजिक जो बिल्ड होता है ना बिल्ड करते हैं ना लॉजिक वो तेरा अच्छा बनता है प्रीफिक्स अभी तेरे को ऐसे उसमें का फॉर्मूला बताओ तुम कैसे अप्रोच करोगे ऐसे कुछ वो लीड कोड में कैसे क्वेश्चन थे अगर तुम्हारे पास ये आ रहे हैं तुम्हारे ये करना है परफॉर्म भी अगर उन्होंने किया ना तब करना पड़ता है और अगर पूछा तो कुछ बोलना है अरे दो टेस्ट होता है अरे पहले क्या होता है पहले कोडिंग एप्टीट्यूड होता है वो कोडिंग राउंड ये सब होता है वो ये करना पड़ेगा ये ऐसे कोड आते हैं वो तुझे करना पड़ेगा
Okay. Any other doubts? Anyone? Any doubts, sir? Got clarity now? Yes. Okay. Now you tell me. So the other problem of squads of Cadence algorithm we will see now. The basic Cadence algorithm we have seen, but it is extended to some other problems also. Because you don't expect everything is purely the form of Cadence algorithm. We use Cadence algorithm to solve different kinds of problems also. So now let us see one more problem on this, sir. At least by lunchtime we'll understand the problem. After lunch we'll solve it. Okay, now? Right. Look at this. So, what is the count, sir?
80
88, huh?
80
80.
yes
Okay. Now let us see the next problem on Cadence algorithm.
अरे क्वेश्चन पेपर जैसा रहता है वो थोड़ा ही सब हार्ड डालेंगे कुछ इजी भी डालेंगे बहुत सारे क्वेश्चन रहेंगे अरे 3-4 तो रहेंगे ना क्वेश्चन मैं
Okay. Next question is maximum sum circular subarray. Maximum sum circular subarray. Problem number I'll tell you, sir, one second. The problem number is 918. Lead code problem number 918.
918 problem.
Lead code problem number 918. So we will analyze that problem, sir, first. Lead code problem number 918. First we'll read it and understand it, sir. before lunch, and then after that we'll continue with that. Okay, no? Problem number 918. Yes, maximum sum circular subarray. Okay. Okay, no? Just read it, sir, everyone. Given a circular integer array nums of length n, given a circular integer array nums of length n, return the maximum possible sum of non-empty subarray of nums. Okay. Here also we are trying to tell me the maximum possible sum of subarray of any length. You take anything. Okay, nums. First tell me what is circular array. That's what is given explanation of the word sir. Very simple, sir. Well, how we are proceeding in our before array, sir? We are proceeding that finding maximum sum of subarray till last element. But what do you do in circular array? After last element, again you come back to first position. So that also we have to consider. I hope understand. Yes. So when you consider that also as the first position, then definitely your max sum will vary. Am I right, everyone? Am I right, everyone? Yes, sir. Your sum will now vary because when you are going from front to the top, back to the front again. So that should be considered again when you are also getting the maximum sum. Okay? So now we'll analyze it. So now we'll analyze. Let us take the first test case first. Look at the second test case. It will be most interesting. 5 minus 3, 5. So when I take just that original subarray without circular array concept, what is the maximum sum, sir? It is 5. Am I right, sir? Yes. Why? Because if you take 5 minus 3, it becomes 2. If you take 5 minus 3, 5, it becomes minus 3. If you take minus 3, 5, 2. Which is maximum? I have written all subarrays here. Which is maximum? 5. You take only one element, you get maximum sum. Am I right, sir? Yes. If it is normal array, the maximum subarray sum is 5. Okay? Yes. Because if you take only length of one subarray, that will be maximum. If you take length 2, it is less. Length 3 also less. So maximum is only length 1 subarray, that is 5. Either you take first element or you take third element, that is the maximum sum you get. But if it is circular, then what happens? If you start with the last element, go to the first element, 5, 5. What is that? Is the maximum 10 average sum? Yes. You go with any other, it will be less. You go with any other, it will be less. Sir, I'll go like this otherwise. So let's say I'm just starting with first element 5. I'll write otherwise. See, this test case is 5 minus 3, 5. Okay. Length is very small. Easily you can use Karan's algorithm. I start with 5. I go to 5 minus 3. Which is maximum? Which is maximum? 5 plus minus 3 is minus 2. It's reducing. Maximum is 5. Okay. Right. So that means it's reducing. So I drop this. I start and give here. Maximum is 5 as of now. So minus 3 plus 5. How much you get it, sir, now? 2. What is but maximum, sir? 5. So we only have that 5 as a maximum. Okay. So in normal Karan's algorithm, it is the 5. Correct, sir? Yes. When you extend to the circular, that means after this I'll go further, sir. So what is the maximum sum here, sir? 5. 5 plus 5. 10. Yes, I'll take this subarray. Now maximum is 10. 10 minus 3. 7. No, I don't take that. Okay? I hope you understand. Okay? That means either I should take till this. Okay? What is the maximum? 10. What is the maximum? 10. If you extend that subarray, 10 minus 3, how much it becomes? So tell me now. 7. If they reduce it, we stop it. You start new subarray. Minus 3. Minus 3 plus 5. 2. It's not maximum. Maximum is 10. I hope you understand. I hope you understand. Because in Karan's algorithm, what we do? Either we extend or we start the new subarray. Whichever is maximum, that will take it. Alright, sir? Yes. So that means the answer is 10 here. Then how to solve this problem, sir? That means it should even go till the beginning. So you have to keep that condition and then do it. Am I right, everyone? Am I right, everyone? Yes. Okay. So shall we continue this after lunch?
Yes.
Okay, now this problem, how do we solve it? Yes. I hope you understand the logic. How can we do it here? Okay, right, sir? So let us meet for the lunch.